Greetings everyone, this is Mr. Mull. Today I'm doing a podcast on some basic elements of the periodic table, specifically what a group or a family is and some common properties that are found within those groups. So we're going to go ahead and get started. First off, I'd like to look at the basic organization of the periodic table. Okay, so looking at the very top, I see the numbers 1 through 18. Those are called the group numbers or family number. And you may also see the old school notation 1A, 2A, and it goes across. So either one is fine. We're going to go ahead and look at the groups today and some of their common properties. And a group is a column, okay, up or down. So those are our groups. We could also look at on the periodic table what's called a period. And a period is a row. So there are 7 basic periods of the periodic table. And typically periods don't tell me as much information about how elements behave. Groups or families are going to be more specific for properties, but it's good to know the period number in case we're talking about the number of electrons, and it deals with electron shells, how many shells there are. We're going to learn all about the difference of the periods. What I really want to focus today on is the families or groups. Okay, families or groups. They're called families because they have some common properties, such as people who are in a family. So we're going to take a look at some common families today. First family I want to look at, and that you'll need to know a little bit about, is Group 1A or Group 1, the alkali metals. Okay, here they are on the left-hand side here. Excluding hydrogen. Okay, hydrogen is going to behave like a nonmetal. Lithium, sodium, potassium, rubidium, cesium, francium. These are our Group 1A alkali metals. And they're called alkali metals. The word alkali comes from the fact that these things, when reacted with water, form bases. So if, for example, I throw a chunk of lithium into some water, it will actually react with the oxygen in water, and it will form lithium hydroxide, which is a very, very strong base. Okay, very strong base. So it would turn my litmus paper blue, and this is where we get the word alkali, because alkali is a word that is talking about a base. So these metals, when thrown in water, will actually form basic solutions. That's where we get the name. They're actually very, very reactive. And in fact, these types of metals need to be stored in oil. They can't be stored in water. So typically these metals are stored in oil. Super reactive. If I were to throw it into a jug of water, it would literally explode. Another thing about these metals is that they will actually lose one electron to form a cation. Okay, so these elements lose one electron to form cations. Now you can always remember when you lose an electron and you form cations, cations are positive. I hope you don't forget that. Lose one electron to form cation. In fact, all metals are going to have this tendency to want to lose electrons to become stable. Okay, so they want to lose electrons, and the alkali metals really, really want to lose electrons. They're very reactive. In terms of other properties of alkali metals, these are soft, they're malleable, they're shiny, soft, malleable, shiny. Those are some other properties. And in fact, if I were to see a chunk of this on the table, it would be kind of dull because it reacts with oxygen in the air. It wouldn't be as shiny, but if I were to cut it open, I could definitely see in the inside. So these are the alkali metals. It's not a coincidence that these group 1 metals form +1 cations. Okay, they form cations with a +1 charge. No coincidence. Let's go over to group 2. Group 2, alkali earth metals. So we have beryllium, magnesium, calcium, strontium, barium, radium. These guys are going to be metals that also form bases in water, but they're not quite as reactive. So they are quite reactive. And in fact, you know that they're reactive because you did this. You heated up one of these, you lit it on fire, added a little bit of energy, and had a violent reaction with oxygen in the air. So these are our alkali earth metals. They're from group 2, and it's no coincidence that because they're a metal, they like to lose their electrons, and they actually lose 2 electrons to form +2 cations, or positive ions. That's another thing about them. So they just reactions, they just 2 electrons, gave 2 electrons to some oxygen in the air, and they had this violent reaction. So they're pretty reactive too. We're going to go ahead and sail over to the other side of the periodic table, and we're going to look at the halogens, group 7, group 7A, the halogens. Now these guys are nonmetals. And something very characteristic about nonmetals is they're going to do the opposite of metals in most cases. So metals like to lose electrons, nonmetals really want to gain them to be stable. So these nonmetals, these halogens, are actually looking for electrons. They gain electrons. Okay, so that's one of the big things that they do. In fact, looking at a reaction with a group 1 and a group 7 by halogens such as chlorine is gaining that little electron, and the sodium is losing it. And when I have these two combined together, these two anions, cation and anion, we call that an ionic bond. They're attracted to the opposite charge that they form in each other. So these are our halogens. Very reactive. Okay. They like to gain 1 electron to become stable, and they form -1 anions. Anions are negative. You think of N and anions. Another thing about these guys is these are elements that are typically diatomic. Remember, diatomic, they come in 2 packs in nature because they're so reactive. So you would actually find fluorine paired up with another fluorine, chlorine, bromine, iodine, atmium, which you don't see as much. These are diatomic molecules. Another interesting thing about the halogens is that at room temperature, they're the only family that has members that have each type phase of matter. So, for example, chlorine is a gas. Chlorine and fluorine are gases. Bromine is a red liquid at room temperature. And then iodine is actually a solid at room temperature. Another thing these halogens have is that they have very low boiling points. Very low boiling points. Iodine will actually sublime. It will go straight from a solid to a gas if heated very little. Okay, so these have extremely low boiling points as a whole. The last thing I want to look at is we're going to look at the noble gases, also called the inert gases. This is group 8, helium, neon, argon, krypton, xenon, radon. Now, I have a picture here of some neon, and they've actually run an electric current through these, but they would not have a color if there were no current through them. They would be colorless gases. Inert. They are very non-reactive. Now, the halogens like to gain 1 electron. These guys actually don't like to lose or gain. Okay? Neither lose nor gain. They neither want to lose or gain electrons. So they're actually pretty happy. They don't react. They're not going to want to react with anyone. And the reason why they're called noble gases is because, much like nobility, in the olden days, they didn't really react with the common folk. The noble gases don't really react with the other elements. So that's where they get their name for nobility. They can react if you force them to. For example, if I had enough energy, chlorine can form compounds with other nonmetals. But typically, excuse me, not chlorine, sorry, xenon. Erase that there. Just cross that out. Okay, so for example, xenon can react with some of these other elements if you add enough energy. So those are some basic properties of some of the common families in the periodic table, and I hope that was helpful.